Okay, we are going to be looking at absolute value functions and graphing those today. So first off, let's talk about what is an absolute value function. An absolute value function is something written in the form of f of x is equal to the absolute value of whatever your input is. This is what's called the parent function, it's the beginning function. So if I have the absolute value of -3, that's equal to 3. Absolute value of a -2 is 2. Absolute value of -1, 1. Absolute value of 0, 0. Absolute value of 1, 1. Absolute value of 2, 2. Absolute value of 3, 3. And so I'm going to come over here and I'm going to graph it. So -3 up to 3. -2 up to 2. -1 up to 1. 0, 0. 1, 1. 2, 2. 3, 3. And then I'm going to go ahead and fill in with my line. And so I'm going to draw in my line going up and to the left, or to the right, and then do the same thing going to the left. And so when I'm looking at this, my domain, my farthest to the left is an arrow going left. My farthest to the right is an arrow going right. So my domain is -infinity to +infinity. Now let's take our range. My farthest down is when y equals 0. My farthest up is an arrow. So it's from 0 to +infinity. The graph is going to look like a V or an upside down V, a mountain. The turning point is called the vertex. So now we're going to do some graphing by the table. And so the big key point that you need to find each time you're working on these is that value of the vertex. That is the key point of what you were looking for. And so we're going to set that expression, what's inside the absolute value bars, to equal 0, and then we're going to solve. They're going to place that at the center of your table, and you're going to complete the table and then use those ordered pairs to help graph. So let's take what's inside my absolute value, x minus 4. I'm going to set that equal to 0. And I'm going to solve. So if I add 4 to both sides, x is equal to 4. That goes in the center of my table. Now I am going to take and count backwards and forwards from there. So if I go down, 3, 2, 1, up, 5, 6, 7. And I am going to, one at a time, replace my x value with that into the function. So f of x is equal to the absolute value of my number I'm plugging in minus 4. And so each time I'm going to replace that number I'm plugging in with one of my new numbers. So the first one is I'm going to test out what's happening at 1. So 1 minus 4 is -3. The absolute value of that is 3. So that means that I plot the point 1, 3. Now I'm going to do the same thing, but this time I'm going to plug in a different number. And so my next number I'm going to plug in is a 2. So 2 minus 4 is -2. Absolute value of -2 is 2. So at 2, 2 is my next order pair. And so the next number I want to check out is 3. 3 minus 1 is negative 1. The absolute value of negative 1 is 1. So at 3, 1. Now I want to test out what's happening at 4. And so when I do 4, 4 minus 4 is 0. The absolute value of 0 is 0. Now let's check out what's happening at 5. So far, what we've been doing is we've been steadily going down each time by 1. At 5 minus 4, we end up with 1. The absolute value of 1 is 1. So we're no longer going down, but we've now started going up. So each time we went down by 1. So each time we go up, we're going to go up by 1. So when we plug in a 6, we should see that it's going to become 2. And so it's at 2. And therefore, when I do 7, 7 minus 4 is 3. Absolute value of that's 3. And so you don't have to show the work each time. The work is just a tool for us to see what's going on. And so we have the arrow going up to the left. And then we're going to also do the arrow going up and to the right. So when I graph the arrow going up and to the left, it's here. When I graph the arrow going up and to the, up and to the right is there. Up and to the left is on the other side. So now, when we have our function looking like this, we're still going to do the same idea. We're going to take what's inside the absolute value, 2x plus 6, set equal to 0, and solve. So minus 6 from both sides. And so 2x is equal to negative 6. Divide both sides by 2. And we have x is equal to negative 3. So negative 3 is my starting point. And so I'm going to take and go from there when I go left and right. So I'm going to go ahead and go down to smaller x values. So that'll be negative 4, negative 5, negative 6. Going up, negative 2, negative 1, 0. And so I'm plugging in each of these values. Again, I'm plugging them into that function. 2 times something plus 6, and then we'll take the absolute value of that quantity. And so I'm going to plug in a negative 6 to begin with. So 2 times negative 6 is negative 12 plus 6. And so that's going to be the absolute value of negative 6, which is 6. And so I'm going to check out my next one. So when I have it at negative 5, so negative 5 times 2 is negative 10. Negative 10 plus 6 is negative 4. Absolute value of that is 4. So I'm going to check out what's happening at negative 4. Negative 4 times 2 is negative 8. Negative 8 plus 6 is negative 2. Oops. Which is going to give us a value of 2. So this time we're changing by going down by 2 each time. So what do you think it's going to be when we get to the 0? Or get to the negative 3? It's going to be 0. So negative 3 times 2 is negative 6. And so 0, and that's going to give us 0. Again, you do not have to show the work each time. This is just so that you can kind of see what's happening as I'm working through these. If you want to talk it through or use your calculator, do so. So let's check out what's happening. So we said that was 0 at negative 2. Negative 2 times 2 is negative 4. Negative 4 plus 6 is going to be 2. So the absolute value, that's 2. So now we're no longer decreasing by 2. We're starting to increase by 2. So looking at that pattern, we should see these next 2 increase by 2. And once you start finding the pattern, I'm okay with you using the pattern to help graph instead of using completely on the table. It's like when I have negative 1, I'm plugging in. I'm plugging in negative 1 times 2 is negative 2. Negative 2 plus 6 is 4. That's going to be 4. And if I do the last one where it's 0, 0 times anything is 0. So I know it's going to be 0 here. And so 6 plus 0 is going to be 6, which is going to give you 0. Or which is going to give you 6. So now let's plot that. Negative 6, I went up to positive 6. Negative 5, I went up to positive 4. Negative 4, I went up to positive 2. Negative 3, I'm at 0. Negative 2, I'm at 2. Negative 1, I'm at 4. And at 0, I'm at 6. So this time I have the same idea happening with my graph. I have that V happening. But my graph is a lot thinner. And so now I have a thinner graph here. My domain, still the farthest back to the left I can go is negative infinity. The farthest to the right I can go is infinity. My range, the lowest I can go, is 0. The highest I can go is my arrow, so that's positive infinity. Let's do the next one. This time, the only thing I have inside my absolute value is x, so x equals 0. So that means my center of my chart is 0. Now, f of whatever I plug in is equal to the absolute value of whatever I plug in plus 5. And so when I check this out, what's going on is I'm plugging in the numbers. So we go smaller than 0, so negative 1, negative 2, negative 3, and bigger than 0, 1, 2, 3. So I'm going to test out negative 3. So the absolute value of negative 3 is 3 plus 5, 8. I'm just going to talk this through. So if we plug in a negative 2, absolute value that's 2 plus 5 is 7. If I plug in a negative 1 absolute value is 1 plus 5, 6. I plugged in a 0. 0 plus 5 is 5. And so I'm just keep on changing what I'm plugging in each time and looking at that chart. So let's go ahead and start doing the positive side. If I plug in a 1, 1 plus 5 is 6. I plug in a 2, 2 plus 5 is 7. Plug in a 3, absolute value 3 plus 5 is 8. And so you see that pattern. We increase by 1 here, we would increase by 1, or decrease by 1 if you're thinking about going from left to right. So I went back to negative 3, and I go all the way up to 8. Negative 2, I'm going all the way up to 7. Negative 1, 6. 0, 5. 1, 6. 2, 7. 0, 8. And so I'm going to go ahead and draw in my line. So going to the right goes up, going to the left, we go up the other way. So again, I'm not changing my domain. My domain is staying the same. But I did change where I stopped at, so I'm going to go ahead and my lowest value is a 5 this time, and I go all the way up to positive infinity. This was a little scarier looking. We have 3x plus 2 that we're setting equal to 0. So I subtract the 2 from both sides. I get negative 2 over here is equal to 3x. And so x is equal to 2 and negative 2/3. So when I have negative 2/3, I know my y value is going to be 0 inside here plus the other. So let's go ahead and find out what happens. F of 2/3. So 3 times a negative 2/3 plus 2. And so that's going to give me a negative 2 plus 2 is 0. So that gives me that 0. Now, when I'm doing my counts, I'm going to count down, but I'm not going to count down to where it's a negative 1 2/3. I'm just going to go down to negative 1, negative 2, negative 3. Going up, the next number up from that is 0, 1, 2. So we have this 1 point that's just kind of floating out here at negative 2/3. I'm at 0. I know that's the point I'm going to be turning around at, but we're going to find what's happening at other spots. So when I take and plug in, I'm just going to plug in each of the whole numbers. So like when I plug in a negative 3, and negative 3 times 3 is negative 9. So negative 9 plus 2, which gives us a negative 7. So 7 is what the absolute value is. So now let's go ahead and go to the next one. So when I plug in a negative 2, that's negative 6 plus 2, negative 4. And that's 4. And so I'm going to plug in my next one. Negative 1. 3 times negative 1 is negative 3. Negative 1. And that's going to give me a 1. Now let's start going back up the other side. And so when I have a 0 here, 0 plus 2 is 2. When I have a 1, one times 3 is 3, and that's going to give me a 5. And when I have a 2 here, six plus 2 is 8. So it's important to check it whenever those numbers are not here. You may have to actually do a little bit more plugging in because you're not going to have that mirror. It is going to go back up on each ways, but it's going to look slightly different because we're not exactly centered in there. So at negative 1, 1. At negative 2, I'm up at 4. At negative 3, I'm up at 7. Now let's go the other way. At 0, I am at 2. At 1, I'm at 5. At 2, I'm at 8. And so I'm going to go ahead and draw in my arrows. Going to the right and going to the left. And so my domain, I'm going to end up covering everything. So it's still negative infinity to infinity. My range, my lowest value is 0, and I go all the way up till I get to positive infinity. What's different here on number 5 is we have a negative in front. And so we're going to start the same way. We're just going to set what's inside the absolute value, x plus 1 equal to 0. So we have x is equal to negative 1. So that's my starting number. Counting down, 0, 1, -2, -3, -4, 0, 1, 2. And so I'm going to figure out what's happening here. We have f of whatever I'm plugging in is equal to the negative of the absolute value of what I'm plugging in plus 1. And so like if I plug in a -4, I have the negative absolute value of -3. And so that's a negative of 3. So -3. So that means everything over here is going to end up being negative because there's nothing added or subtracted at the end. So if I was to do this again, -3 plus 1 is -2. Absolute value of that's 2, and then make it negative. So what I'm counting by is it looks like I am, as I'm going over here, I'm going to be increasing by 1. So I should see that pattern continue on until I get to that vertex. And so here, if I plug in a -2, -2 plus 1 is -1. Absolute value of that is 1, so -1. Now I'm going to plug in a -1, and that's going to give me a 0. Absolute value of 0 is 0. The negative of that is 0. So all I did was increase by 1 each time. So what I should be doing next is starting to decrease by 1 each time. And so let's see what happens. So if I have f of 0, that's a negative of 0 plus 1. So negative of 1, absolute value of 1, so -1. And so if I keep going, you're going to see that pattern is going to continue. 1 plus 1 is 2, -2. And 2 plus 1 is 3. Absolute value of that is -3. So I'm going to go here and graph those points. And so we have -4, -3, -3, -2, -2, -1, -1, 0, 0, -1, 1, -2, 2, 3. And so I'm going to come in and graph that line, going left and right. We have this time our absolute value is upside down. And so when we're graphing this, our domain, we're still going all the way to the left and all the way to the right. So it's still negative infinity, infinity. But my range, now my lowest is at these arrows, so negative infinity. And I stop here at 0. And looking at this next graph, when I set my 1/2 x plus 1 equals to 0, we can solve for x by moving the 1 to the other side, so it becomes a -1. Let's get rid of the fraction. Multiply by 2. And so x is equal to -2. And so that is my starting point. Again, same ideas we've been working with. This time we're going to be dealing with some fractions and some decimals. If you would like to work with decimals, you can go with decimals. If you want to work with fractions, you can work with fractions. I am going to work with decimals. 0, 1. And so now I'm going to plug that into my function. F of my number is equal to 1/2, or for me to think about this easier, That's the same thing as 0.5 times my x value plus 1, and then I'm going to subtract 4 from that. So the first one I'm plugging in is -5. So that's -2.5 plus 1. Take the absolute value of that. That's going to give me a -1.5. Take the absolute value of that. And so that's going to give me a 1.5 minus 4, which gives me a negative, oops, not 3.5, 2.5. So that's my first ordered pair. Now I'm going to do the same thing with the next number. And so we have a -4. So half of -4 is -2. -2 plus 1 is -1. And that's going to be 1 minus 4, which is -3. Go into my next one. We have a -3 that we're going to take half of, which is going to give us a -1.5, which gives us a -0.5. And so that's going to give us a -3.5. And so now we're going to plug in a -2. -2 times 5 is -1.5. -1, that's going to give us a 0. 0 minus 4 is a -4. At this point should be our turnaround point. This is our vertex. And so we're going to see that mirrors going back the other way. This time we only went down and changed by half. See how that number here is going to affect how much we're changing by each time. So at -5, I went down to 2.5. At -4, I went down to -3. At -3, I went down to -3.5. At -2, I went down to -4. At -1, I started going back up to -3.5. At 0, I was at -3. And at 4, I was at -2.5. I'm going to go ahead and draw in my absolute value. And I'm going to draw my absolute value going the other way. Sorry to get my pen first. And so if I look at this, my domain, I'm still going from -infinity to +infinity. My range is going to go up my lowest value, which is here, which was at -4, to +infinity. So on the last set, we have a system or a piecewise function. And so we have two different types. So when we're going to the left of 4, we're going to use this top one. And that's going to lead us to where we have an open circle at 4. And since this is not an absolute value, you don't need a chart. So we need to find the start point. And so to find the start point, you do y equals -2 times the value of x that we're trying to find, so 4, plus 1, so -8 plus 1, which is -7. So the order pair I'm going to plot is 4, -7. And that's an open circle, and I'm wanting to go to the left. And so next I need to identify my slope. My slope is what's being multiplied times my x. So my slope is -2 over 1. And since I need to go left, that means that for it to be negative, it needs to go up and left. And so I'm going to come up here, left, 2/1. And just keep going on up. Then I'm going to draw in that line. And so my line is going to go up as we go to the left. And I had that open circle to start with. So now let's go ahead and graph my absolute value. So when I'm graphing the absolute value, again, I'm starting off with that 4. So I know that's going to be my first number I can have in my chart. I know that I need to go right from there, and that it has a closed dot. So the step 1 when you have absolute value is take what's inside your absolute value, x minus 3, always set it equal to 0, and solve. So that gives me 3. 3 is not greater than or equal to 4, so that means I don't use this point. So now I need to take, and since I don't have my vertex plotted, I just need a couple of points to plot that line. So I'm just going to do 3. So at 4 minus 3, the absolute value of that is absolute value of 1, which is 1. When I'm doing 5 minus 3, that's going to be a 2. The absolute value of that is 2. And if I did the absolute value of 6 minus 3, that point is 3. The absolute value of that is 3. And so I have those points. So starting off at 4, I go up to 1. I have a closed dot there. And then I'm just going up 1, right 1 each time, drawing my line as it goes to the right. And just remember that that point that I started with this time was closed. This point was open. And so now to find my domain, well, when I go to my left, I have an arrow, so it's a negative infinity. My change point, I have a spot that is filled in, no gaps, and then to the right is positive infinity. So my domain is negative infinity to positive infinity. Now my range. My low point is down here at -7. My high point is that arrow. At -7 is a dot, open dot, so it needs to be a parenthesis, all the way up to positive infinity. So let's do our last one. And so let's take our first, which is an absolute value. We set what's inside our absolute value equal to 0. So x is equal to 0. And so now I check and see, is 0 less than or equal to -3? And that is false. So that means that I don't need that information. So that means I just get to start with -3 and choose a couple of points to the left. So -4, -5. And I'm not going to be plotting my vertex. And so we just get to plot like the vertical line. I get to plot the horizontal, the sloped line. And so when I do 2 times -3, the absolute value of that, so we have -6. The absolute value of -6 is 6 minus 4, and so that gives me 2. So that's my first point. Now let's check the next one. And so when I plug in a -4, get -8. 8 minus 4 is 4. When I plug in a -5, I get a -10. Absolute value of that is 10. Minus 4 is 6. So I'm going to come back here to -3. I'm going to go up to 2. This is a closed dot as I'm going to the left. And I'm going to fill those numbers in. Oops, those are not the points I should have plotted. At -3, 2, -4, 4, -5, 6. And then I'm going to draw those in with my arrow. And again, starting that off with is a closed dot. So now let's go ahead and see what happens on this middle line. So when I look at that middle line, there's no x in the function, and I have 2 open circles. So if there's no x, that means I have a horizontal line. And so my horizontal line is going to be at the value of -5. So this is my y value. These are my 2 x values. So I have -3, -5, and 2, -5. And so that -3, -5, draw all the way over to 2, -5, and that's my line. And the last one I have, we have an x, is a closed dot as I go to the right. So I need to find my start point. And to find that, I always just take and plug in what that original x is. So 2 minus 2, which is 0. So my ordered pair is 2, 0. And it's closed, and I'm going to the right. And so, and my slope is 1/1. And so if I'm going right, that means I need to rise in order to keep that as a positive slope. Drawing my line. And I had that closed dot at the end. And so I have an arrow going to my left. So I know it's -infinity, comma. And here, I have the hole being filled in with the dot. Again, the same thing here. And then an arrow, so it's going to go to positive infinity. And so on range, my lowest down I'm at is at that -5, unioned with, I start off at 0 and go up to positive infinity.